Hi students, in the previous lessons we have discussed what are signals, what are systems, what is the need of mathematical abstraction of signals and systems, how to classify the signals, what are some elementary signals, what are the different operations we can perform on signals, etc. In this video series or in this lesson, we are going to discuss about types of systems or classification of systems. As we said earlier, classification of different things will help us to study and analyze things in an effective manner. Similarly, classification of systems also will help us to analyze and study the systems in a deep and effective manner. Now, consider an RC circuit. It can have some inputs. The inputs of this RC circuit can be voltage or current, and output also can be voltage or current responses. This is an example of a system. Another example is an automobile moving on the road. This is an example of the system. The movement of the accelerator and the steering are examples of input signals, and based on that input signals, how the wheels are responding. That is an example of the output response. And the car itself is a system. Consider a digital filter. Here, we provide a noise affected signal as the input of the system, the digital filter, and it will give you the reconstructed or noise removed signal. And another example is a robot. Here, the electronic control signals can be considered as the input signals, and based on that, the robotic arm or different parts of the robot will move. That can be considered as the output signal. In the case of a radar system, the electromagnetic waves which are reflected back from the target is an example of an input signal, and a radar system will process that and display that on the screen, which is an example of the output signals. So in all these applications, system is something. It can be an interconnection of components, interconnection of circuits, interconnection of subsystems. It can be anything. So the main function of the system is to transform the input signals into an output signals or respond to the input signals to produce the output signals. So systems can be viewed as a process which transforms the input signals into an output signals or respond to the input signals based on the design of the system. So generally, we can consider system as a black box where it has so many input terminals where we provide the input signals, and it has also one or more output terminals which will provide the output signals. So in this lesson, our main concentration is on systems, especially types of system. The general objective of this lesson is that students will be able to analyze the classification of systems based on its properties. The first specific objective of this lesson is to identify the given system as a different class based on its properties. The second specific objective of this lesson is to interpret the need for linearity and time invariance in the analysis of signals and systems. The third specific objective of this lesson is to resolve different systems mathematically. Now let us analyze how can we classify the systems. The systems can be classified as linear and non-linear systems, time invariant or constant parameter systems, and time varying or time varying parameter systems, instantaneous or static or memoryless systems, and systems with memory or dynamic systems, causal and non-causal systems, continuous time systems and discrete time systems, analog systems and digital systems, invertible systems and non-invertible systems, stable systems and unstable systems. These are the classification of systems. Now let us analyze each and every system separately in different videos. A detailed lecture note for this lesson is provided in the description box of this particular video. I request you to download that lecture note and study for a better understanding.